is equal to x square plus y square plus z square, v is equal to xy plus yz plus zx, w is equal to x plus y plus z. Then find del of u comma v comma w divided by del of x comma y comma z. That is to find the Jacobian for the function u, v, w. Here we have three functions u, v, w with respect to three independent variables x, y and z. First take the given problem, that is u is equal to x square plus y square plus z square, v is equal to xy plus yz plus zx, w is equal to x plus y plus z. We know that Jacobian for the function u, v, w with respect to the variables x, y, z is given by determinant of del u by del x, del u by del y, del u by del z, del v by del x, del v by del y, del v by del z, del w by del x, del w by del y, del w by del z. In the first step, we have to find all these values. After finding all these values, we have to apply determinant formula and simplify. We get the value of Jacobians. For that, first find del u by del x, del u by del y, del u by del z. Hence, we get del u by del x value as, here we have to differentiate this u with respect to x partially, means we have to treat y and z as constant. So, del u by del x value as, here differentiation of x square is 2x. Similarly, we get del u by del y value as, we have to treat x and z value as constant to find del u by del y. Hence, we get del u by del y value as, you have to differentiate this y square with respect to y. Hence, we get 2y. Similarly, del u by del z value as 2z. Next, we have to find del v by del x, del v by del y, del v by del z. For that, we have to treat this function, that is v is equal to xy plus yz plus zx. So first take del v by del x. Here we have to differentiate this v term with respect to x, means we have to treat y and z as constant. So here also x term, here also x term. Hence we get, here take y as constant, here differentiation of x is 1. Plus here also take z as constant and differentiation of x is 1. Here y, z both are constant, so differentiation of constant is 0. Hence we get del v by del x value as y plus z. Similarly, del v by del y value as, here we have y term, here also we have y term. So we have to differentiate this v term with respect to y, means here x is constant, take as it is, into differentiation of y is 1, plus here z is constant, take as it is, into differentiation of y term is 1. Hence we get del v by del y value as x plus z. Similarly, del v by del z as, here we have z term, here also we have z term. Treat y as constant, here treat x as constant. Hence we get del v by del x value as y plus x. Next we have to find del w by del x, del w by del y and del w by del z. So for that function, we have to consider this function, that is w is equal to x plus y plus z. Hence we get del w by del x. First you have to differentiate w with respect to x, means y and z as constant. So differentiation of constant is 0. So differentiation of x is 1. Hence we get del w by del x value is 1. Similarly, del w by del y as, here we have differentiation of y is 1. Hence we get del w by del y value is also 1. Similarly, del w by del z value is also equal to 1. After finding all these values, we have to substitute in the formula of Jacobian and simplify. We get the value as del of u comma v comma w divided by del of x comma y comma z. Substitute all these values, we get 2x, 2y, 2z, y plus z, x plus z, y plus x, 1, 1, 1. In the next step, we have to simplify the determinant. We already discussed how to solve the determinant, that is 2x into, here x plus z into 1 is x plus z, minus y plus x into 1 is y plus x, minus sign of 2y into, here y plus z into 1 is y plus z, minus y plus x into 1 is y plus x, plus 2z into y plus z into 1 minus x plus z into 1 is x plus z itself. Take as it is. In next step, here plus x and minus x gets cancelled. Here also plus y and minus y gets cancelled. Here plus z and minus z gets cancelled. And simplify, multiplying 2x, 2y, 2z inside the bracket, we get as, here 2x into z is 2xz, minus 2x into y is 2xy, minus 2y into z is minus 2yz. Here minus into minus, plus 2y into x is plus 2xy, plus 2z into y is plus 2yz. Here plus into minus, minus 2z into x is minus 2xz. Here we can cancel the term. Here plus 2xz minus 2xz gets cancelled, plus 2xy minus 2xy gets cancelled, and plus 2yz minus 2yz gets cancelled. The remaining, we get the value of del of u comma v comma w divided by del of xyz value as 0. Here all the values gets cancelled. Hence we get the Jacobian value as 0. This completes the problem. Here to solve the Jacobian problem, The important thing is we have to expand the determinant value carefully and simplify.